So I just installed this stuff here. This is all the power components, and I will plug it in and test it. We should get 6 volts at the input to 386 and 6 volts to the quad NAND on those pins, and we should have a 12 volts, for example, at like C17 here, which feeds all that power. So if we just a 3S LiPo, let's see, set that, plug this in, and it wants to wander away. There we go. If we, let's see, ground pin 8, 6 volts, pin 14, also 6 volts, C17 is up here, ooh, 12 volts, which hopefully you can see that. So the power is working. I think it's safe to move on to the next section, and I will be building and testing the audio amplifier in the next video. So the audio amplifier, if we go back to our circuit description, it says LM386 amplifier output of speech signal composed of 2N7000 field effect tube mute circuit to shut down when launch receive, at the same time produce audio oscillator composed of 74HC00 sidetone, make the headset to follow, drops on clicking audio transmission. So that's a bunch of nonsense, but basically what's saying is there's a LM386 here audio amplifier. That's a pretty common audio amplifier chip, and it's got this 2N7000 field effect transistor here, which is used to mute. So when the key is closed, if we follow this line through all these things here, you can see the key is closed. This line here will be grounded, so it'll, through the diode and resistor there, it'll ground the gate of this FET, of this FET, which will stop audio coming, any audio that's coming out of that 386 will be stopped, won't get past here, and so all that will be going into the headphones will be the side tone from the quad NAND. So I will build, what's the best way? I think I'll just build the regular stuff. Maybe I'll start from this LC filter here, out to the output here of CP5. No, I'll build it all the way out to the phone jack so we can plug in a speaker and listen. And we can also put in the diode resistor and the key so we can ground it and check that the muting works. Well, I installed the audio amplifier and the muting circuit, so now I can try it out. I got a straight key here. I don't have any speakers, so I'll have to I'll tangle up. I have to use some earbuds. I'm not sure you'll be able to hear if they're not in your ear, but we can try. Speaker, and then if we plug it in, I can hear. I'm not sure where the microphone on this camera is. I can hear it. If I want it to be louder, I can add some 60 hertz noise and it gets louder. And if I keep that noise there and key down, it goes away. In fact, all the noise goes away. So, audio amplifier and the mute circuit are working. Well, we got the audio working. So now I'm going to build the side tone, because that I think will be interesting. Let's make sure that works. So that'll just be, these 4 NAND gates are all in one chip. And it looks like it's connected to the key. So get the input, and then it'll start oscillating, we should hear it in the headphones. Added in sidetone oscillator, which is built around this 74HC00 quad NAND. So now we can test it out. Straight key, plug in the headphones and recorder, and let's see. So here I got the scope probe, I got one end to ground, and I will just hold the other end there on C14. It's a little too small to use a nice grabber. And if we turn this on, so you can see there's some sort of DC offset. 0 is here, so it's about, I don't know, 3 volts or something, but key down, and it's kind of a square wave. I don't know if you can read at the bottom. There's the frequency there, 1.46 kilohertz. So definitely on the high side, but it works. So now that we have power, audio amplifier, sidetone working, I'll build the mixer and oscillator up to this RF gain control here, and we can just inject a signal there, and we should be able to hear it mix down on receive.